saw the parts of anesthesia machine starting from the oxygen cylinder source and gases cylinder source, where it is from the pipeline, central pipeline supply through the wall outlet or the so-called pendants, ceiling or wall pendants. Then the inlet into the machine through the hanger yoke assembly, and pressure gauges fixed at that level to show the pressures uh, from the pipeline or from the cylinder, and then the pressure being reduced to a safe level by the pressure regulators, and then supplied to the flow meters, from where we can control the volume of gases required by opening the valves, needle valves, with the color coding and fluting for safety purposes. And then the assembled gases or oxygen and air mixture delivered from the flow meter assembly passes through the vaporizers if we are going to use a vaporizer inhalation agent, or if we don't want to use them, maintain only with some TIVA, we can even bypass the vaporizers and allow these gases to come out to the common gas outlet. And from the common gas outlet, it will be delivered to the patient by the breathing systems. So we have seen up to the common gas outlet in the last class, sans the vaporizers. We have not discussed about the vaporizers because I told it was a huge topic by itself. So from exam point of view and your practical knowledge of what you should know about vaporizers, first we will see some points on vaporizers, and then after completing that we will go on to discuss about the breathing circuits, which is also an important part of the entire anesthesia delivery system. Okay, so I'll share my slides with you. Is it visible?
Yes, sir. Visible, sir.
So we are going to see the vaporizers. And then starting with some historical interest. So you are seeing a picture where somebody is being anesthetized in the early 19th century. So what are the names of the equipments used to anesthetize a patient here?
Schimmelbusch mask, sir.
Schimmelbusch mask. Okay, very good.
4 to 6 layers of cloths, tissues.
Schimmelbusch mask comes with a cloth layer, okay, or a gauze. What is the purpose of that cloth or gauze?
So for a prolonged delivery,
Prolonged delivery.
to maintain the
What is the
constant.
correct terminology you should use for this? What agent are you going to use to anesthetize the patient here?
Ether.
Ether. Okay. So ether, is it a liquid or a vapor?
Liquid, sir.
It is a liquid. So can liquid be directly poured onto the face?
No, sir.
No, sir. So what should happen to that liquid?
It should be changed to a condensation form.
It should become a vapor. It should have become vaporized and it should become a vapor, like a gas. So last class we saw what was the difference between a vapor and a gas. What is the difference between a vapor and a gas?
Substance above its critical temperature is gas. Substance in gaseous phase, but below its critical temperature is a vapor.
Vapor, and it can be compressed into liquid. So ether is a substance below its critical temperature which has been condensed or compressed into a liquid form, And even at room temperature, once you spill it out into the open atmosphere, it will evaporate and become a vapor. Okay. So to vaporize that, you need these gas pieces. So it increases the surface available for vaporization by having the. Is it better to use a closely woven cloth, or is it better to use a gas piece? Many layers of gas piece.
Many layers of gas pieces.
Many layers of gas piece, because there is a gap there and the surface for vaporization will be more. One common question in those days, we used to get an examiner from All India Institute Delhi called Dr. Gode, and he used to ask the students, we all used to wear white coat when we go for the exams, isn't it? So the examiner used to ask the student, can I cut a piece of your white coat and use it in the Schimmelbusch mask for anesthetizing the patient by this method? The answer is no, because the white coat is very thick and it has not got gaps. The threads are all very tightly woven. Whereas in a gas piece, the threads are all loosely woven and there is a lot of gaps through which the vaporization will be much faster and better. So you should have a loose knit fabric like gas piece, and that too you should not have too many layers. You should have an optimum of 4 to 8 layers only. Beyond that, it becomes, what will happen if you use 20 layers of gas piece, thinking that you will have a more surface area for vaporization?
Will be ineffective, sir.
Why ineffective? What
Takes time.
There will be lesser.
See, if I put a thick cloth on your mouth and face, what will happen?
Smaller
Suffocate,
the
sir.
patients.
You will be able to, your resistance, you will feel choking, you will be smothering, you will be feeling very high inability to breathe. So thicker the cloth becomes, more difficult it is to breathe through that. Okay. So many points are there in this small equipment called Schimmelbusch mask. It should have a proper frame to cover the nose and mouth, and it should have 4 to 8 layers of loosely woven gas fixed onto the frame, so that the ether that is poured will not be a direct liquid touching the face, and it will have more chances to vaporize and become a vapor for inhalation, and induction will be much more faster. So that is the first equipment that is being used. What other things he is using? What is he holding in the hand? Where is he pouring from the ether? Where is he pouring that ether from?
From a bottle.
Bottle. What is the name of that bottle? It was a Schimmelbusch mask that you have. Then I am showing you the Schimmelbusch mask in close-up. Then the bottle that is being held is called Bellamy Gardner bottle. Okay, that was specifically used. Sometimes some centers where you go for your practical exam still have all these things. Unfortunately, if you happen to go to Armed Air Forces Hospital, Pune, they have an anesthesia museum where they have all these very old anesthesia equipment still in store. So, by bad luck, if you happen to go there, they may have all these things on the table and ask you to identify them. So, Bellamy Gardner bottle is the one. Do you see any peculiar arrangement in this bottle here, where it is being poured? How many tubes are jetting out from the cork or the cover?
Two, sir.
2 tubes are you able to make out? One tube like this, another tube like that. What is the purpose of these 2 tubes?
To reduce the negative pressure getting created inside the bottles.
It will allow atmospheric air to enter in. Okay, one tube, the liquid will pour out, and through the other tube which is facing up, air will be sucked in or air will enter, and that air will help to vaporize as well as create a pressure for the liquid to drop out. Okay, if you use only one tube, after a few drops falling down, the pressure will become equal and no more liquid will fall down. But if you want a continuous fill of the liquid from the bottle, you have to have two tubes, one for air entrainment into the bottle and another for dispensing or spilling the liquid through this bottle. Okay, see, so much things they have thought about in those days for continuous pouring of that particular agent. So this is what, if you closer look, you can see it is having a rubber cork. And why this bottle is amber colored?
Light sensitive.
The liquid ether will get
Oxidized.
in light, sunlight. So it all things that are photosensitive drugs will be kept only in amber colored bottle. Many of our anesthetic agents are all photosensitive, so they should be stored only in amber colored bottle. So under what type this anesthesia classified? Is there any name for the method of anesthetizing this patient?
Inhalation.
Inhalational injection.
Inhalational agent, okay.
Open
type.
It is called open drop method of anesthesia, okay, because you are dropping it from the bottle directly onto the patient's face. So it is called open drop method. What do you understand by this open drop method? Why the word open is used? They could have just said ether dropping method. Why they say it is open drop method? So silent. Because
Since
patient
it
is open to atmosphere. Okay,
open.
this is an anesthesia breathing technique or system where patient is open to atmosphere. He is breathing from the atmosphere. We are not supplying any fresh gases to him using a machine like what you do nowadays with oxygen air or oxygen nitrous oxide. We are not supplying anything from the machine. Patient is getting anesthetized by inhaling atmospheric air mixed with the ether that we are pouring on the face or on the Simulbus mask where it gets vaporized. So air ether mixture is being inhaled by the patient, which makes him unconscious or which takes him to the surgical plane of anesthesia. So patient breathes from the atmosphere, and where does he breathe out?
Same way through
into
the
the
Why so much delay in answering that? So he is breathing out again into the atmosphere and spreading the vapor to all of us. So if you give open drop method, not only the patient will get anesthetized, after some time you will also feel anesthetized because you are also going to inhale some of the fumes. So patient is open to atmosphere. He breathes in from the atmosphere and he breathes out into the atmosphere. And that is the reason why it is called open method. In this same open method, some examiners may ask you, is it really open or semi-open? That means what is the difference between open and semi-open? That is the next point that you should have a clear idea about. All of you would have read about, when you read about breathing systems, you say it is classified as open, semi-open, semi-closed, and closed. Isn't it? Have you all read about that or thought about like that?
Yes, sir.
What is the difference between a open and a semi-open method of breathing system? In open, I said patient is breathing from the atmosphere and exhaling back, or inspiring and expiring both into the atmosphere. But if you hold the Schimmelbusch mask like this with a big dome, will
They'll
we
be
be completely
breathing.
exhaling all the exhaled gases, or will we be able to rebreathe some of the exhaled gases?
He'll be breathing this.
Because the mask has got a volume, isn't it? So some exhaled air may stay there and he may be rebreathing that exhaled air. Then it becomes a semi-open method. But if you hold the mask above the face and giving a small gap, what will happen? Will you be able to rebreathe?
No, sir.
No
No.
rebreathing.
So it is, some people say that you must hold the mask with a gap between the face and the mask and pour the ether onto the Schimmelbusch mask, and whatever vapor is formed and patient has to inhale without the mask being closely fittingly applied to the face, then it is called open method. If you apply the mask like this in a tight fit manner and produce a closed volume close to the mouth and face, there is a possibility he can rebreathe some of his exhaled gases, then it becomes a semi-open method. Okay, so that way they can argue like that, but even if you say open, nothing wrong in that. Okay, what are the features of open method? All these are all very old techniques, but worth remembering and worth knowing, because as I told you, sometimes you may suddenly be caught unaware of all these questions. Does it require any very costly equipment like
There is no
like
rebreath.
No, sir.
There is no reservoir
Ah.
bag, sir.
is it mobile wherever you want? Can you take the Schimmelbusch mask in your coat pocket and then anesthetize the patient? You require only these two things, a mask and the bottle, isn't it? So
Yes, sir.
patient's airway is open to atmosphere, he breathes from and to the atmosphere. The volatile agent is vaporized by atmospheric air by patient's own respiration, and it requires very limited equipment like one mask and one bottle. What agents were used in the olden days by this open drop method?
Ether.
Ether.
Ether, then
Chloroform.
chloroform. Even the Queen Victoria of England was given chloroform by open drop method only as a labor analgesia for her 8th delivery. You know that? And James N. Simpson, J.Y. Simpson was the anesthetist who gave that, and this was a popular thing. So they used chloroform, ether, ethyl chloride, and sometimes they use trilene also, another agent called trilene, which is more potent than ether. Have any one of you seen this ethyl chloride?
No, sir.
No, not at all. Okay. It is also one of the obsolete or old-time anesthetic agent. The ethyl chloride bottle will look like this. Okay, and you can see it has got a lever-like thing here, and this is the cap which is closing that. This is the bottle plastic cover. On top of that, there is a small projection with a hole, and that hole is covered by this cork-like thing which is attached to the lever. If you press this lever, can you guess what will happen? Why this sort of arrangement is there? Anybody knows what is the boiling point of ethyl chloride?
16 degrees, sir. 16.
15 degrees. Very good. So what state the agent will be present in the bottle?
It will keep boiling at below sub-room temperature itself.
So what will happen? What will be the pressure inside?
It will be in high pressure. So once you release the lever, it can
how
come
much
out in
high
very high
pressure?
concentrations.
Very good. How much high pressure? 15 degrees is the boiling point, and room temperature is almost 28 to 30 degrees, correct? In Chennai. So it is twice, the heat is twice. So how much pressure it will develop inside? At 15 degree, it should equal to 1 atmospheric pressure. At 30 degree,
2 atmosphere.
2 atmospheric pressure. So once you press this lever, what will happen to the gas? I mean the liquid, will it come out as a liquid or it will come out as a spray, vapor spray?
Vapor spray, sir.
It will come out as a vapor spray. Okay, that is why this lever and this small delivery nozzle is all kept here. Okay, so the gas is under high pressure, and this again is an amber colored bottle because this is also photosensitive. And we used to use this ethyl chloride spray for 2 purposes in the earlier days. Any idea? Who has been Kiranmay, are you been answering this?
Yes, sir.
Okay, so what are the uses of ethyl chloride? One is to initiate general anesthesia by spraying it onto the simple bush mask before you spray the ether or chloroform. And the second reason, it can cause refrigeration analgesia. Once you put the spray onto the skin, you will see icicles forming on the skin. So it will reduce the temperature of the skin and it will form a very cold sensation which temporarily will numb. So in the olden days, whenever the surgeon wants to do a incision and drainage, the so-called IND procedures, they used to spray this ethyl chloride onto the abscess skin, and momentarily there will be some numbing. Within that short time, they will put a 11 blade needle and make a nick and let out the pus. So it is used as refrigeration analgesia also, because the boiling point is about 12 to 12.2, less than 15 also. So the pressure inside is twice the atmospheric pressure at room temperature. So it comes as a spray, it comes out as a jet of spray, and it was used for induction of GA by before open drop method of giving ether or chloroform, and it is also used as a topical anesthetic because of its refrigeration property. Luckily, all these things are all historical of interest questions. So anyway, just to start the class with them, stimulating questions, but I'll just go by it. Now, again, going back to the same old equipments. I don't know how many of you have had a chance to see a machine with these things. So what is shown here?
Goldman bottle, sir.
Goldman bottle is, I'll show you later. This is not Goldman bottle. This is the famous person's invention.
Boils in
Man who formed the anesthesia machine, and still it is being called by his name.
boils bottles.
Boyle's bottle. It's called Boyle's bottle for both ether and trilane. Okay. So what are the parts of the Boyle's bottle? Of course, you won't know all these things. There's a picture to describe all that. I'll just show that straight away. And you can see there is a copper U-like tube going there. And there is a stem with a head which can be pulled up or pulled down. It's called the plunger. Okay? And this is the lever to operate the bypass system. Variable bypass is one of the techniques of vaporizers using. So the fresh gas flow coming from the flow meter can be adjusted. If you keep it in off position, can you see this word OFF here?
Yes, sir.
So if it is in off position, all the fresh gas will go through straight without entering this bottle. That means no vapor will be carried. And the trilane also in off position, you will deliver only the gases straight away coming from the flow meter. But if you lift the lever to this 1 position, 2 position, 3 position, or on position, this is the 4th position is completely on, then all the gases will go into the fully on position, all the gases will go into the bottle, pick up the vapor, and then go out through this and join the back bar mainstream and go to the common gas outlet. And if you want to use trilane, the same way you can use. And can you use both these vaporizers at the same time?
No, sir.
How many people vote for no? How many people vote for yes?
There is a switch to
Silent lock is
of
there.
trilane.
Trilane lock only if you are going to use the closed circuit. Supposing it is an open spontaneous breathing, patient attached to McGill circuit, Mapleson A circuit, and patient is being anesthetized by spontaneous ventilation. Then can you open ether and trilane together? The answer is yes, we can, because there is no interlocking system like what you have in your modern workstation. Okay. Only if you select the closed circuit where the gases will go through the circle absorber with soda lime, as I told you in the last class, then the lever will not operate. And that is why the closed circuit selection is also called the trilene lock in the older machines. Okay. So this is called the plunger. This is the cowl. All these things are essentially things to improve the vaporization, so that it can. What will happen if you push the plunger? The gases which are, you lift the lever to 1 or 2 position, then part of the gases will only be coming because it's a variable bypass. Not all the flow coming from the flow meter will enter, only part of it will flow into that. At the time, instead of keeping this plunger fully out, you press it, then you know what will happen? The gases will enter through this gap between the plunger and this copper tube that you are seeing, and there will be a lot of holes here. And through that, the flow meter fresh gas flow which is coming will be pushed under the surface level of the liquid that is present here, and a lot of bubbles will be formed. And every bubble, will it increase the area of surface area of vaporization or reduce the surface area?
Increases the surface area.
Increase the surface. So that is why the boil bottle, I will show you how to describe that. You know how to, can anyone make a description about the boil bottle after I have told you all these features now? What sort of, comparing to the modern day, all of you have read about Tech 3, Tech 4, Tech 5, Tech 6,
Yes.
isn't it? Which are
Yes,
all
sir.
modern vaporizers. What does the Tech stand for?
Temperature compensation.
Temperature compensated. Excellent. Is there a temperature compensation in this bottle? Do you see
No,
any
sir.
temperature
No, sir.
compensation?
No, sir.
No. So this is not at all temperature compensated. So when the, how does the ether which is poured or the trilene which is poured into these bottles, how do they become a vapor? Where do they get the heat from?
So trilene need not be heated because its the boiling point itself is below room temperature only.
Trilene below room temperature. Both of them are self-vaporizing. Between the two, ether and trilene, which has got a higher boiling point? All these things are very important even when you read about or learn about your modern day workstations. Okay. So whenever there are one or more vaporizers used in the machine, the agent which has a lower boiling point should first come. Then only the agent with the higher boiling point should be fixed. Okay. So this is called the upstream, this is called the downstream. The ether bottle is in the upstream. Trilene bottle is in the downstream. So whenever you have two or more agents coming, you will have to fix the agent with a lower boiling point first, which is called the upstream, and the agent with a higher boiling point in the next position or beyond that, which is called the downstream position. Okay? Otherwise, what will happen? This agent with the higher boiling point may condense into this and mix with that and contaminate this. That is the reason why you want to always have this. But nowadays, one of the reasons why you have this interlocking system, the selector tech, is to avoid this problem of the agents getting mixed up with each other. So simultaneously, if you use both the mixtures, and if one with the higher boiling point is situated in the upstream and one with the lower boiling point is fixed in the downstream, then the one with the higher boiling point may condense into the vaporizer of the next lower boiling point agent. So that is the reason why we have nowadays what is called the selector tech switch, which will allow only one vaporizer to operate at a time to avoid this problem of getting the contamination with the lower boiling point, I mean higher boiling point agent into the lower boiling point agent. Okay. So these are all the parts that you are seeing in the picture. Now this is another museum specimen. Can you identify this?
Oxford Vaporize.
Oxford. Only Oxford. What is Oxford? Is it the name of a person or some place?
University.
It is a university, just like your Annamala University, your Bharatidasan University. Okay,
Yes,
it
sir.
is one of the Oxford and Nuffield are the two famous UK-based universities where a lot of medical inventions have happened. Okay, so Oxford, but two persons who designed that, they were working in Oxford University. Who are those persons whose name is also incorporated into this machine? They are called Epstein and McIntosh. Okay, so these two are the scientists or the anesthetists who designed this. One is called Epstein, another person is called McIntosh, and they worked in Oxford University. So, as a loyalty to the university, they included the university name also, and this is called the Epstein McIntosh Oxford Vaporizer. And this is the vaporizer actually. From where you can get this targeted tubing coming on. Then there is a what is this structure looking like?
Bellows.
Bellows in the ventilator. So you can use this bellows. Then there is a targeted tube. Then there is a expiratory or a pressure limiting valve, APL valve, and there is a mask. So you can attach a mask or you can intubate the patient and connect the endotracheal tube to that. And by pressing the bellows, you can control the ventilation after paralyzing, or you can allow the patient to breathe spontaneously without paralyzing. Then you need not use this. Then still the gases will be delivered there. So this is a very old portable type of agent, either using anesthesia machine, which is called Epstein McIntosh. So the description, it's a draw over, concentration calibrated, flow over, temperature compensated by water jacket. So this big, this is a handle to carry the whole thing. This is a water jacket to vaporize or give heat for the, because I told you this bottle is not temperature compensated. In this bottle, if you use ether, it gets the heat from the air surrounding this bottle, and that heat will be transferred to the ether inside by the bottle, which is the container. And what will happen if that air which is surrounding the bottle gives off its heat? What will happen to the water vapor which is mixed in the air? Once the heat is given, will the air surrounding the bottle become cooler or hotter after it donates the heat?
Cooler and condensed.
It will become cooler. Once the air becomes cooler, what will happen to the water vapor which is normally not visible to your eyes?
It will condense and
It will condense into water droplets and it will settle on the glass. Okay. So after about half an hour or 45 minutes of use of ether in a second or third position, you will see the bottle will be covered with full of water droplets. So in those days, jokingly, we used to say, ether bottle is sweating to anesthetize your patient because it forms the water droplets condensed from the air surrounding that. So once the bottle gets cooled, the coolness is transferred to the bottle. Will it increase the vapor or will it decrease the vapor formation?
it decreases the output, sir.
Reduces the
Decreases
output.
the output. Yes. And that is the reason why they incorporated a water jacket to supply a constant heat for evaporating or vaporizing the ether so that you will get, that is why it is called concentration calibrated. Whereas here, in the initial stage, when you open the lever, a lot of ether vapor will go, and as time goes by, this condensation will happen, the temperature will drop, then the amount of vaporization will go down. Even if you keep it in the same position without altering, the amount of vapor coming out will be very much decreased compared to the initial flow of vapor. Okay, so this is not temperature compensated, and that is the reason why nowadays we have all our vaporizers which are fully temperature compensated, so that if you keep it at 2.0 whatever vapor you get initially by the flow of the fresh gas into the vaporizer will be continued throughout if you have a temperature compensation. If you don't have that, the output of the vapor from the vaporizers is likely to vary, and that is the reason why we have what is called the temperature compensated calibration fixed concentration of calibrated or delivered supply is used in this, and this is more accurate and precise. So this was a later development compared to this bottle. So 1940 or so, Boyle developed this machine and this bottle. Later on, people invented this about 5 to 6 years later to avoid this problem of water condensation and the vapor output decreasing is compensated by the ether bottle jacket that is being there. So if you want to describe the Boyle's bottle also, you have to describe it as variable bypass, plenum or draw over, bubble through, not concentration calibrated, not temperature compensated, and it is not agent specific. So supposing you don't have ether, you can even pour trilene and give through the same thing. Or so for example, if you don't have trilene, you can put ether. Sometimes in the olden days when we are using this, due to some reason, the bottle may crack. There may be some mishandling and there may be a crack in the bottle, or the bottle itself may break. In that situation, we simply pour the agent into the other bottle and keep this bottle completely shut off till we can replace the bottle and use this. So this is not agent specific, and this is kept outside the circuit. You cannot use these two inside the circuit system. It is always kept outside the circuit system. So vaporizer outside the circuit, VOC. Okay, that is these are all the descriptions that you have to say for any vaporizer, which will be subsequently seen. Okay. Now you have to understand a few terms before you understand about the vaporizer. One is called the difference between gas and vapor. Already Trisha madam has nicely described that. And you have to know what is about saturated vapor pressure. You have to know what is a boiling point. You have to, of course, last class we saw what is the boiling point, and now Hiranmaya madam also said what is the boiling point. The temperature at which the vapor pressure equals the atmospheric pressure is called the boiling point. And how to calculate the gas concentration, what is splitting ratio, what is variable bypass, what is measured light flow, what is latent heat of vaporization, what is a specific heat, what is the thermal conductivity. So all these physics terms you have to understand. So let us go one by one. What is the difference between gas and vapor? We have already talked about it. Vapor is the gaseous form of a substance that is normally a liquid or solid at room temperature, but below its critical temperature, whereas gas is a substance that has no shape or volume and occupies the space where it is present, and it is above its critical temperature. So below critical temperature, it is a vapor. Above critical temperature, it is gas. If you remember, this simple point also is very quite enough for your exam purposes. So if the examiner asks you what is a vapor and what is a gas, any gaseous substance below its critical temperature is vapor, above its critical temperature is gas. That's that much of a answer in the Viva is accepted. Now coming to what is a saturated vapor pressure, is a liquid that evaporates into a space above it, and then what will happen? The pressure will increase, and there will be a point where equilibrium will be reached, at which the rate of evaporation equals the, it will also condense because it is below its critical temperature. Any liquid which is capable of becoming a vapor will also be constantly becoming condensed and then become back to the liquid form also. So the point at which the rate of evaporation and condensation are at equal within the space that is they are occupying, that is called the saturated vapor pressure. Okay. Definite boiling point, that also we have seen. Now, how to calculate vapor concentration using this saturated vapor pressure and atmospheric pressure? This is one point which you all have to have a clear understanding. How to calculate the vapor concentration? How much of vapor concentration you will be delivering. For example, I will tell you, if you are going to use sevoflurane as an open drop method onto the patient's face using the Simulbus mask, what percentage of Simulbus, sevoflurane will you be delivering to the patient? What is the saturated vapor pressure of sevoflurane?
164 millimeters mercury, sir.
164 millimeters of mercury. Are you sure? Or making a guess?
Sir, it is
158.
150 plus millimeters mercury.
We have to talk in terms of bar. Okay? So it is about 20.1 bar, and the atmospheric pressure is roughly 100.2 bars. So the saturated vapor pressure divided by the ambient pressure will give you the multiplied by 100 to make it percentage. That will give you the percent. So if you use sevoflurane as an open drop method technique, you will be delivering how much percent? You can see that here in the answer. Be delivering 20.1%. Is it safe for the patient?
No, sir.
No.
Very high.
It is a very, very high concentration. So you will be rather causing euthanasia and not anesthesia. Okay? So that is the importance of saturated vapor pressure. Similarly, you can think of desflurane. It has got a vapor pressure of 88 bar. So 88 divided by 100 into 100. What is the percentage?
88%.
88%. So that is also very high, which is not suitable for giving anesthesia. Okay. Now the next term that you have to know is, what is splitting ratio?
So it is the percentage of fresh gas flow to enter the bypass.
Enter the
And
bypass.
Ratio of fresh
into
gas
the
flow passing through the variable chamber to the fresh gas flow passing through the bypass chamber, sir.
It is not called variable chamber, it is called vaporizing chamber.
Vaporizing chamber.
So the fresh, as I explained in the earlier slide about the ether bottle and trialing bottle, fresh gas flow coming from the flow meter is split into two components. One part, as I told you in the lever, if you keep it in one position, one small amount of gas will go. If you keep it in two position, more amount of gas will come into the bottle. Keep it into three position, and on position, I told you all the flow will come into the bottle and go out. Whereas in our modern vaporizers, we have the percentage dial setting, 0.5%, 1%, 1.5%, 2%. So depending upon the dial setting, a part of the fresh gas flow coming from the flow meter will enter into the so-called vaporizing chamber, which contains the volatile liquid anesthetic agent, pick up the vapor, and then it will exit through the other end of that vaporizing chamber and join the mainstream of flow, the fresh gas flow, which is going without entering the chamber with the so-called bypass. All of you would have experienced when you travel in the highway without entering a town nowadays. Every town you can bypass and go. It's called the bypass road. Similarly, the fresh gas flow which is not entering the vaporizing chamber is called the bypass flow. And those which is entering the vaporizing chamber is only eligible to pick up the vapor and then come and join. And depending upon the dial setting, it will deliver or it will contain vapor to that amount of concentration. Okay, so it is one method of setting the concentration and also picking up the vapor for anesthetic use. So that is the splitting ratio. It is a ratio between the quantity or volume of gas that is entering the vaporizing chamber to the volume that is not entering or going through the bypass chamber. So the ratio of bypass gas divided by the gas going through the vaporizing compartment is referred to as the splitting ratio. Okay. What is latent heat of vaporization? This is another important physics point which you have to know. What is the importance and what is the first definition of latent heat of vaporization and what is its importance?
So
Sir,
it is
the
the temp
energy needed to convert a liquid into vapor at a constant temperature, sir.
Okay, so it is the conversion of a gas, I mean a liquid or a solid into its gaseous form by using a particular amount of heat, okay, or at a particular temperature. Okay, so that is the latent. Latent means hidden. You don't obviously supply or give any heat to that liquid or the agent. So it is taking the heat from atmosphere or the container, wherever it is able to see it. We are not able to see because we are not supplying any visible heat to the liquid. It is called latent. Latent means hidden. So we are giving a hidden heat for vaporization. So the amount of heat that is needed to convert a unit mass of liquid substance into gaseous phase at a constant temperature is the definition. And this latent heat is a very important quality of a volatile anesthetic agent, which determines how much it will become a vapor from the liquid state. Okay. So if the latent heat of vaporization is very high, will the vapor formation be high or low?
Low and results in cooling.
No, if the latent heat of vaporization is supposing, let us say or arbitrary number, latent heat of vaporization is 41 for one liquid and 21 for another liquid. Which one will become vapor faster?
21.
Which one? That requires lesser
The
heat,
lower.
isn't it? So
Yes.
latent heat of vaporization is an important factor to determine how much of vapor will be formed by that. Right? Now there is another term called specific heat. What does this specific heat apply to?
So that
This specific-
number of calories required to increase the temperature of 1 gram of substance to by 1 degree Celsius.
Excellent, excellent. Specific heat is the quantity of heat required to raise the temperature of 1 gram of substance by 1 degree Celsius. Okay. So this, where does this term used for? In vaporizers.
For constructing the vaporizing and the vaporizers, sir. Internal design
The
and,
material out of which we have to make the container for holding the volatile liquid agents. Okay. That only we have to choose by the specific heat. Okay. So that container will be able to supply the latent heat for the volatile agent to become a vapor. So it is a quality which we have to see in the choosing the material for making the vaporizer container. Okay. And what is thermal conductivity? And to which particular thing it applies? Does it apply to the volatile liquid or the material to make the container?
so it applies to materials, sir.
It is again applied to the material conduct. So it is a material measure to ability to conduct the heat. So that whatever material out of which we are making our vaporizer, it should be able to take the heat from the surrounding atmosphere and then supply it to the liquid inside. So it should have an ability to conduct that heat. That is called the thermal conductivity, and it should be able to get a heat quite faster. That is specific heat. So the specific heat and thermal conductivity both are in relation to the material out of which we are going to make our or construct our vaporizers. It is not related to the volatile anesthetic agent that we are going to use for anesthesia. Only latent heat of vaporization is applicable to the liquid agent that we are going to use. The specific heat and thermal conductivity are applicable to the material out of which we are going to construct our vaporizer. Is it clear? Right. Now, what is variable bypass vaporizer? Which we have already seen by the splitting ratio. We know by splitting ratio, we have a variable bypass. We can define it as total background gas flow that enters unit is split into two streams. And the smaller stream, which acts as the carrier gas, passes through the vaporizing chamber containing the vapor. Then it becomes saturated with the agent Then the remainder of the gas bypasses this chamber and goes. And that is the total measure that goes out to the common gas outlet. That is the principle. And this is where the splitting ratio comes. How much of gas, for example, if you are using oxygen 1 liter and nitrous oxide 2 liters, a total fresh gas flow of 3 liters is coming out from the flow meter. Out of which, by using the 1% setting, only 1 liter goes into the vaporizing chamber, the other 2 liters goes straight. So the splitting ratio becomes 2/1. Okay, and then at the end it carries the vapor, and again the total flow becomes 3 liter at the other end or the exit part of the vaporizer. Okay, so this is the variable bypass vaporizer. But what is measured flow vaporizer, which we have already seen in the last class when we talked about desflurane?
Sir, how much ever is the flow? Only determine flow. Only the flow which is set is delivered. In variable bypass, it is the percentage of flow. Here it is the quantity which is fixed.
I said the definition in last class very, very clearly. Let me see how many of you remember that.
So the vaporizer output and diluent gases are dialed separately.
There is no fresh gas flow directly entering the vaporizer at all. In measured gas flow, the desflurane, for your example, which you are familiar with, we pour the desflurane into the vaporizer, and there is a heating mechanism to heat up the desflurane to convert the liquid into the vapor form. And there is no fresh gas flow like your oxygen and air or oxygen nitrous oxide coming to pick up this vapor. Instead of that, there is a separate tube which is delivering the vapor directly into the mainstream of the fresh gas flow that is going. Okay, that is called the measured flow vaporizer. So what you have to remember is the measured flow has a separate independent stream of vapor carrying gas that is added to the fresh flow. And to deliver an accurate concentration, the vaporizer must measure, adjust for the fresh gas flow and deliver the vapor accordingly so that the dial setting concentration can be delivered. Okay. Now I am showing the saturated vapor pressure at 20 degrees of some agents, starting from the old agent ether, halothane, fluorine, desflurane. The question is, what will be the concentration if these agents shown here are used as an open drop method at sea level? Already I have told you the formula how to calculate the concentration.
Yes.
Saturated vapor pressure by ambient pressure into 100.
100.
Yeah. What is the answer ultimately? That is the formula. One word answer. It will be equal to the saturated vapor pressure value what is given there. For example, I told you sevoflurane is 21% because the saturated vapor pressure is 21 bars, out of which ambient pressure is 100 bar at sea level. So it becomes 21%. Similarly, I told you desflurane has a high vapor pressure, 88.5. So if you use it as open drop, it will deliver 88.5. Ether 59. So whatever is the saturated vapor pressure of a particular agent, that will be the value of the concentration also if it is used in open drop method. Okay, so that is to make you understand the importance of SVP. So ether will be 59, halothane 32, and fluorine 23. So whatever value is there. Now, why ether is the only agent used by open drop? Even though all these agents you can use by open drop, but you will ultimately land up using a very, very high concentration. But ether also you find it is 59%, but still ether was used as the sole agent for open drop method. What is the reason? Safe. Is it safe to use ether or not? Because you have not seen the ether at all, there is no answer. Ether is a very safe agent, even though you are delivering 59% because of the SVP at 20. It is inflammable, but it is safe for the patient because it doesn't cause that much of depression. It requires a very, very high dose of ether to kill a patient or make the patient go into very deep state of coma. Okay. So ether has a wide safety margin. That is a large gap between the therapeutic dose and lethal dose. And this on the adage in those days is an average anesthetist with average skill cannot kill a patient with ether. This is the saying. That is why so many patients survived in those era of ether also. And ether has got a very excellent analgesic quality, which is lacking in all our modern inhalation agents. Even though they are all derivatives of ether, none of our modern anesthetic agents have any analgesic quality. But ether had an excellent analgesia also, apart from making the patient unconscious and maintaining the plane of anesthesia. That is why many patients, when they were anesthetized with ether, did not have much pain and did not require any much analgesic also. Now coming to the next part of it, how vaporizers are classified. Is there only one classification or there are several classifications?
Several classification depending on.
There are several classifications based on the various factors which are the characters of. So first classification is by what is called the vaporization method, which is can be flow over. Flow over means it is what is the other name for flow over? They are also called draw over. That is the fresh gas flow which is entering the vaporization chamber just comes on the surface, picks up the vapor and goes to the outlet. Okay, so it is also, it just flows over the surface, or it is just drawing the vapor from the surface. It is not entering into the depth of the liquid. So that is why it is called flow over or draw over. And bubble through, that is not available in the modern machines, but it is available in the ether bottle which I showed you, where it can form bubbles to pick up more vapor. Or it can be a combination of both, as what we had in the ether and trilene bottles. And the modern vaporizers all have wicks. You know, wicks means tiri in Tamil. Just like the Shimal bush mask having the gas layer, the same woven material is spread into the vaporizing chamber to increase the, see how the application comes. About 150 years ago, people thought of using the gas for vaporization. The same thing, if you surtify and make it into a wick like thing, three, it becomes wicks. So the same principle is allowed here to increase the surface of vaporization. And then injector type like your desflurane. Any old anesthesia vaporizer which also belong to the injector type? Do you know the name? The museum specimen again, which was used for delivering ether at a constant concentration. Just now I showed you a picture of a equipment constructed in Oxford, similar to that, where heat is supplied to vaporize the ether, and ether is delivered by as a measured flow through a separate tube. Any idea what was that equipment? It was called copper kettle. Okay? That also heated the ether and delivered the ether vapor directly into the fresh gas flow without the fresh gas flow entering the vaporizing chamber. That is called the injector type. So we can classify the vaporizer based on the vaporization method. Second is regulation of output concentration of vapor. That is by either variable bypass or measured flow, which we have already seen. The third compensation is temperature compensation, which can be automatic or by supplied heat or with no temperature compensation. Nowadays, electronic is there. So there are several methods by which we can maintain the temperature so that a constant output of vapor will be there. Fourth is agent specific. Nowadays we have vaporizers which are meant only for use for the particular agent. For example, you cannot use halothane in sevoflurane vaporizer or sevoflurane in halothane vaporizer. Even though in the examiners may ask you, can you use halothane in enflurane vaporizer and enflurane in halothane vaporizer? Of course, none of you, even I have not seen an enflurane vaporizer, but this is a very common tricky question asked in the Viva also. Can you use halothane in enflurane vaporizer? Think about it and tell me before the end of the class, otherwise I'll tell you the answer later. Then the fifth type is called plenum or draw over vaporizer. What does the word plenum mean?
High
Resistance,
resistance.
Huh?
High
Resistance.
resistance.
Pressure. Plenum means pressure. Vacuum means empty. Plenum means pressure. So if the fresh gas flow which is coming from the flow meter enters with the pressure inside the vaporizing chamber, that is called the plenum type. Okay. Those which are being drawn into the vaporizing chamber by the patient's own inspiratory effort, that is called the draw over vaporizer. Okay. So the boil bottle can be both plenum and draw over. If you remember the earlier slide, I have put both because if you are using spontaneous respiration, the patient's inspiratory negative pressure will suck the gases and bring it over into the vaporizer. That is called draw over. Whereas if you are using controlled ventilation, the flow coming from the flow meter directly, because of the higher pressure there, it will enter the vaporizer. That is called the plenum vaporizer. Okay. So that is the two methods. And the vaporizer can be kept inside the circle system, inside the circuit or outside the circuit, VIC or VOC. Last class I showed you how you can use the Goldman vaporizer. In the last slide, I think I showed you how with inspiratory limb you insert the Goldman vaporizer and the corrugated tubing can be attached further down to that, and you can deliver halothane through that for anesthetizing the patient. So these are the 6 qualities based on which we can classify the vaporizers. And based on this classification, can you give some examples?
So, vaporizer inside the circuit is what we use nowadays, sir.
Vaporizer inside the circuit is what you are using. How do you say that?
Outside the circuit.
It is all on the back bar, isn't it?
Yeah, outside
It is all outside the circuit. If you are going to use it attached to the canister within the circuit system, then it is called inside the circuit. Okay. Now the starting point is from the hanger yoke assembly. From there it comes to the flow meter. From flow meter it is going to the vaporizer. From vaporizer gases are coming partly to the breathing system, which is a circuit system or the spontaneous system. Okay. But if you are going to use the vaporizer within the circuit system, it is called inside the circuit. If it is outside the circuit system, it is called vaporizer outside the circuit. So anything on the back bar is always outside. Please remember that. Don't get confused. Okay. So I will show you what are all the things that you have. For example, method of regulating output, variable bypass or measured flow. You have the ether vaporizer. You have all the tech vaporizers which you are using nowadays. They are all variable bypass method of output, regulating output. Whereas measured flow, I told you one of the old specimen is copper kettle, and you can also add your desflurane vaporizer to that measured flow. Then method of vaporization, flow over with wick is all our modern tech machines. Without wick is Goldman vaporizer, which I showed you in the last class. You remember? I think Hinmay was not there. She is not able to recall what is a Goldman. And bubble through, you can have it with the ether bottle. Actually, it should be ether bottle. And the injection is desflurane. Location inside the circuit, you are using only these two. What is OMV? Anybody knows the expansion of
Manual.
Minimal.
miniature vaporizer? Very good.
Miniature.
Oxford miniature vaporizer, which is similar to Goldman bottle. That also can be used within the circuit. All the other tech vaporizers are outside the circuit. Please remember that. And temperature compensation, thermocompensated by altered flow, supplied heat, combination of both, no compensation is ether bottle. So all our tech vaporizers are all altering the flow by the bimetallic strip. Okay, that is how the temperature compensation happens. Agent specificity, agent, all tech vaporizers are agent specific, whereas Goldman, the ether bottle, trilene bottle, all these things, they're non-specific. You can use anything. And resistance, plenum is high resistance, or gases coming into the inlet of the vaporizer comes under high pressure, and that is the plenum actually. So all the tech vaporizers. And drop over where there is a less resistance, or it is the inspiratory effort which is drawing the gases into the surface to come in contact with the surface of the liquid is Goldman and Oxford miniature, ether bottle, all these things are there. So the sixth method, you have six examples. So tech vaporizers are all can be classified under these categories. So how can you normally describe any vaporizer? You can say concentration calibrated, plenum type, variable bypass, flow over the wicks, temperature compensated, out of circuit. So all these things can be incorporated. And if any examiner asks you keeping a Tech 6 or a Tech 5 vaporizer in front of you, which will be kept in the exam as a spotter, you will have to give all these descriptions. Okay, so please remember that. Now, what is the difference between boiling point and evaporation? So this is not much of use. And vapor pressure we have seen already. The significance of vapor pressure also we have seen. The another important thing is by plotting a graph or a chart, you can easily find out which agent will form which is the most volatile agent and all those things. Now comes the spotter identification. Identify the vaporizers shown here. Each one of you would have seen one type in your hospital attached to your workstations, because so many companies are there. So based on your experience or handling of these machines, you may need to identify what type or which company is manufacturing all these things. Any idea? Which is I think this is the most common type most of the hospitals will be using. Am I right?
Yes, sir.
Dragon.
Drager. So the answer is this is a Tech 5 modern vaporizers. Okay, this is Tech 7, another improved advanced version. And this is called the Drager vaporizer or Vapor 2000. And this is called Sigma Delta or Penlon vaporizer. Okay, this is I just thought because these are all the common models that will be available. Now the question is, what are the agents used in this vaporizer A? Now this is the Tech 5 vaporizer. You have 4 vaporizers because they are all agent specific. You have to use a specific agent. What agents are being used in that? Can you identify from left to right? What is this vaporizer used? This is halogen?
Enflurane.
The orange color is enflurane. What is red color?
Red is halogen, sir.
Red is halogen. Very good. And purple?
Isoflurane.
Isoflurane.
Yellow sevoflurane.
Sevoflurane. So please don't make a mistake. Orange color is enflurane, which we are not using, which we don't have. but the examiners may be asking you. So orange color is enfluorine, red color, which is also become obsolete. None of the people are using it now. Red color is halothane. These two you will easily identify because you are very familiar with that, isofluorine and sevofluorine. And what will be the color of desfluorine?
Blue color.
Blue color. Okay, right. So that is the, what are the features of Tech 7 vaporizer, which is the more recent introduction.
It is electrically driven measured flow with injection type of vaporizers.
All Tech 7 vaporizers are like that. Tech 6 is what you are talking about. Electrically driven with a measured flow for desfluorine. That is Tech 6, not Tech 7. You don't find desfluorine here at all. You find again the halothane for red, yellow, purple. So the latest model Tech series delivers isofluorine, sevofluorine, enfluorine, and halothane efficiently, and it has a volume of 225 ml, no spill systems. That is the biggest advantage. Earlier, all the other models, when you tilt them, the liquid agent from the vaporizing chamber will come into the common chamber and will deliver a very high concentration. So that spill mechanism is completely avoided in the modern Tech 7 vaporizer, which is, so if the vaporizer is tilted or inverted, no spill will happen, help to protect internal components also. What is the purpose of the knobs projecting on the top in the picture D? That is, this is D, which is pendulum sigma, and what is this knobs for?
So for
Remove the
locking into the mounting chamber.
Selector Tech interlocking system. Very good. It is a Selector Tech mounting system knob, which will prevent the use of two simultaneous things. So identify the vaporizers shown here. This is again some older things, again for the purpose of making you know something which is not commonly used nowadays. Of course, from reading this and the color coding and other things, what is this vaporizer used for?
Halothane.
Halothane. But what is the commercial name written here?
Fluothane.
Fluothane. Okay, it is marketed as fluothane, not as halothane. And this is the Tech 2 vaporizer for halothane. Okay, very old type. And you can see this is the filling port. This screw thread you have to remove and just pour the liquid into that, and you can see the level here, and you can see the dial is in the front position. You have to push and rotate. Then the next version, they change it onto the top. So this is on the face of the vaporizer, this is on top of the vaporizer. So that was the improvement that was made in Tech 3 halothane vaporizer. And again, this projecting screw has been removed from Tech 2 and made into a compact thread. And anybody knows what is the purpose of this groove and the top portion here in this cap, which is closing the filling port? Have any one of you had a chance to see this vaporizer, Tech 3?
No, sir.
No. So this cap, you can remove, unscrew by rotating it anti-clockwise. And are you able to see a can you see this small black? There's actually a depression there. So there will be a nut underneath. Can you see something projecting here? What is this for? It looks like a hole, isn't it?
Yes, sir.
So that is the drain tube. Okay. So in the olden days, they said that you should not leave the unused liquid inside the vaporizer because halothane had a preservative which will make the dial become sticky. Okay, so in order to, after the end of the surgery list over is getting over, what you have to do is remove the left out liquid from the vaporizer into the bottle. So to drain that, the top hole will be used to unscrew a nut underneath this assembly. This is the assembly, and you will have a small nut underneath that. So you remove the cap and then fix it onto that, and then you can drain the whole thing, holding the bottle over here, and again fill it up the next morning when you start the list. So that is the reason for that. And in the older machine, and you can see that thing much better here in this, that same spanner like thing which is having, I mean, the gap which is there to unscrew that nut. So again you can see the drain tube here. It is also Tech 3 for isoflurane, and this is the Somni 3 funnel type filler for isoflurane and sevoflurane. So that just I wanted to add these pictures for making you understand. Now, there are different methods of filling the modern tech vaporizers. This is a common question that is asked in the examination. So, what are all the methods you know of, or you have seen in
Key
your
filling.
day-to-day
Key filling.
practice?
Key filling, sir.
Key
Pore
filling, pore filling.
fill.
So, there are basically three methods. One is called the key filling, where you have to have a this is the key for that. Okay, it will have a color coded rectangular portion with a hole, which you have to attach to the bottle and then insert and then turn the bottle upside down. Then liquid will flow through that, and once you finish, you just invert the bottle downwards, it will stop, and then you remove, and there will be a plug to close this, and you insert that plug and close that key filling. This is direct pouring. You can just remove the cap on that and then start pouring. Of course, this will cause a little wastage. Some of them will fall outside. And when sevoflurane was introduced, it was very expensive. So in order to minimize that expense only, other methods like key filling and quick filling were all. And in quick fill, you have an adapter which is fitted to the bottle itself, which you have to insert here and then do the thing. So these are the three methods. And what does the picture show here?
Aladdin
Aladdin
cassette.
Aladdin cassettes, vaporizers with for different vaporizers. Advantages are they regulate anesthetic vapor concentration with electro-pneumatic proportional flow valves. So it works on both the electrical and pneumatic component controlled by microprocessors. So it has a computer element in that. So very different in external appearance. They are functionally similar to conventional vaporizers with a bypass chamber and a vaporizing chamber. So here also it is a variable flow which can decide the and a single electronic control system installed in the workstation can be used for all volatile anesthetic agents, including desflurane. Okay? So you have to simply insert the cassette there and it will deliver the vapor as required. Now, for those who are familiar with this usage of Aladdin, can you name the parts which have been marked here? This is an Aladdin cassette vaporizer for isoflurane, and you have markings here, 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 here. You make it. All of you are familiar or not used Aladdin cassette vaporizers?
Not used, sir.
Not used. Then there is no point wasting time. The parts are, this is called the filler wheel. First locks the key filler and then opens the gas and liquid channels, and overfilling protection system is built in. And this is the key filling system where you have to insert the key filling for filling the, this is the agent chamber. This is actually evaporation chamber. This is the level, liquid level visible. This is the eject handle for easy carrying and replacement of storage. Okay? So you hold this and then insert or pull out That is the handle for that. So only 1, 2, 3, 4, and 5 parts. This is the actual chamber to contain the amount of liquid agent that you use. This is the handle for insertion as well as exit of the cassette into the machine. And this is the filler wheel which you have to rotate to insert this key filling system, and then you can visualize the level of the liquid in this. And this is the CO-fluorine, but here, what is the difference between the two?
The filler wheel is in the front.
Here it is the key filler system. This is the easy fill system. So for the because this is more tedious, now they have introduced this for the same CO-fluorine. Again, both are Aladdin cassettes only, Aladdin cassette vaporizers. From the keyed filling system, they have changed it into easy fill or quick fill system. By just opening and then inserting the bottle, you can fill that. Okay, so that is the difference that you have to make out. So top is easy fill or quick fill. Agent level sighting is in the front, whereas here the bottom is the keyed filling and the sighting glass is at the corner. It is not in the, see, this is the sighting glass for seeing the level, whereas here it is seen very clearly. So this is an advanced model compared to the older model. What is the mode of operation of Aladdin cassette vaporizer? Again, they may ask you, in theory also it may come sometimes. Consists of two parts, electronic control mechanism and portable cassette which is inserted. Electronic control mechanism is in the anesthesia machine, and agent is in a portable cassette that is inserted into the slot in the anesthesia machine, in which the contents of the cassette and dispenses the agent in the stream of fresh gas flow. So as I told you earlier, it's a variable bypass vaporizer. So part of the gases, depending upon the dial setting, will come into the vaporizing chamber, pick up the vapor and go. So each cassette is a liquid sump without control mechanism, and it can be tipped easily, so nothing will happen. And it cannot deliver volatile agent in the absence of mains power, battery backup, or adequate oxygen pressure. All these three are important. Power is important and pressure is also important. And they are functionally similar to conventional vaporizers like bypass chamber and vaporizing chamber. So what is the maximum volume of agent that it can hold? That is the Aladdin cassette vaporizer. What is the volume when the ball of the side tube is at the bottom? So for those who have not seen, it holds up to 250 ml when it is fully filled. And when the ball at the sighting tube is seen, it is about 80 ml or less. And sometimes it gives an alarm, just like your desk fluorine, that if the level goes down, it gives an alarm also, because it is electronically maintained. The safety features of Aladdin: when only 10% liquid is there, alarm message appears. Fresh gas flow in and out of the cassette is electronically measured and for enhanced control. And when the cassette is removed, two spring-loaded valves automatically close to prevent any channels for wastage of gases. In error situation, the valves operate to cut off anesthetic agent delivery. A pressure relief valve opens to the scavenging line if a high pressure is detected in the cassette, or in the liquid level valve measuring device detects overfilling. Okay, so these are all the next thing is, of course, this is a very common thing which you might be asked in the exam, and all of you should be familiar with this equipment. What is this?
Desflurane vaporizer.
This is a desflurane Tech 6 vaporizer. Very good. And this is the working principle. As we have seen already in the last class. You can see here the fresh gas flow from the flow meter. You can see this. So there's fresh gas flow coming and going in a separate channel. And this is the liquid desflurane, which is heated, comes in a separate channel, and then there is a differential pressure transducer. This is mainly to adjust the volume. So you have the variable resistance device. This is the dial setting which is connected to that. So the amount of vapor which is going to come and join here, you can see, will be decided. In this picture, it is much more easier to see that the fresh gas flow is all along going separately. Nothing is entering. The blue dot is the fresh gas flow. None of the blue dots are seen here. And the purple dots are the vapor of the desflurane. So they are going in a separate chamber, and depending upon the dial setting, it is adjusted and it comes and joins ultimately at the outlet only. Okay, so that is the major difference. I hope this picture gives you a good, clear idea about. And why we require, of course, all of you know, desflurane vapor pressure is 681 millimeter at sea level, or 88.2 bars, and it's significantly higher, and it has a low boiling point. And so this is all the features which all of you, I think, know. So the components are flow meter delivery for the fresh gas flow. Number one. Sometimes the ASCII, they may give this picture and ask you. That's why I thought I will put this. So first is the flow meter for delivering the TIM, and 2 is the fresh gas flow which is going there, as I told earlier. And 3 is the vaporizing chamber, and 4 is the vapors which are emanating from that, which is heated up. And then 5 is the travels down the pipe, and 6 and 13, they are the 2 valves. So there are 2 valves here to control the amount of vapor to be joined in the main stream. And 12 is the computer, the vaporizer's brain, which is able to alter the flow of desflurane. That is the differential transducer, controlling valve of 13. And 7 is the desflurane vapor going pipe, and the 8 is the point where it meets. So there's a fresh gas flow which is coming separately meets the vapor which is coming here at this point only. So you can see no fresh gas flow is entering the vaporizing chamber. Okay, it's very clear in that. And the final emergence is at 9th number, and flow in the pipes is has resistance at 2 and 10 in the path, and the 11 is called the differential transducer. Now, can isoflurane be used by open drop method? The answer is no. Why? Again, this is a repetition of old concepts I have told you already. Saturated vapor pressure, is it high? Vapor concentration, what? How much it will be? We have put this isofluranes cannot be used into mark. Saturated vapor pressure is 241. So if you are using it in the open drop method, it will be 33% roughly, okay, more than your sevoflurane. So it should not be used. So what is the function of vaporizer? Vaporizers deliver the correct percentage. That is the thing that already we have seen the difference between. These are all little repetition. I should have removed these slides. What are the safety features in the tech vaporizers? This is another common question which can be asked in your theory as well as in your practical exam.
Selector tech interlocking systems.
Selector tech is there. Do you start with that? Say temperature compensation. The word itself is tech vaporizer. No, so first always mention it is temperature compensated, calibrated for a concentration output. It is color coded. It is specific for a particular agent specific. Okay, all the points that we have already seen. So have interlock or isolate vapors not in use, a clear indication for liquid level, non-spill reservoir up to 180 degrees allowable till, a keyed filler or 4 filler system to prevent filling, and an increase in wick capacity. How to calculate the volume of liquid agent used?
So 3 into fresh gas flow rate into dial percentage.
Yeah, very good. Excellent. This is by Earnreth and Eisencraft. These are the people who described this formula. So dial percentage set fresh gas flow in liters multiplied by 3 will give you that. So for example, if you are using 2% sevoflurane and you are using a fresh gas flow of 2 liters, so 2 into 2 into 3, 12 ml per hour will be the usage of the liquid agent. How to calculate the amount of vapor formed by 1 ml of volatile agent? How do you calculate the amount of vapor formed from 1 ml of volatile agent? For this, you have to know Avogadro's hypothesis. 22,400 multiplied by density of the agent divided by molecular weight will give you the vapor from 1 ml. So for sevoflurane, 22,400. This is a standard Avogadro's number. How many molecules will be there in 1 mole of a substance? So that multiplied by density of sevoflurane is 1.53 and molecular weight is 200. So 1.53 divided by 200, you ultimately get 171.3 ml. That is the amount of vapor. Now identify the following.
Variable bypass
Variable bypass.
vaporizer.
Very good. Variable bypass vaporizer. What is this?
Measured
flow vaporizer. Okay. Just wanted to check whether you are all attentive and able to remember. Okay. So what is the difference between that? We have already seen in variable bypass, part of our entire fresh gas can enter the vaporizing chamber, whereas in measured flow, there is no fresh gas flow. How is the vapor concentration achieved in measured flow? That already we have seen that by using the differential transducer. This is a picture to show what will happen at variable dial settings, how much of gas will enter, how much will go through the bypass chamber. So this is the splitting valve. So what is the dial setting in this last picture?
0.
Zero. So none of the gas is going into the vaporizer chamber. So you have not operated the vaporizer at all. The dial is set at 0. So all the fresh gas flow is bypassing the vaporizing chamber and going directly to the vapor. Okay, right. So what are the methods of increasing the vaporization? That only you have to see fresh gas being filled from the vaporizing chamber. If you use high flow, will it carry more vapor or less vapor? For example, if you are using 6 liters fresh gas flow, 4 liters of nitrous oxide and 2 liters of oxygen, will you get more vapor or less vapor?
More vapor, but in a dilute.
There is not adequate time for vaporization because the gases will travel faster. Okay, that is why in low flow you have a much more. One of the reasons we use low flow today is to get the vapor concentration at a lower setting itself. So the wicks which I told you will improve the vaporization, or you can bubble through that, or that can be by what is called the tech vaporizers. You have baffling where the gases go through just like your diversion for metro. It goes through so many circles. So it takes longer time inside the vaporizing chamber to pick up more vapor. This is called baffling. This is called wicks incorporated. This is bubble through, and this is the difference between a low flow and a high flow. Why selection of metal with good thermal conductivity is important in making a vaporizer? Already we have seen that because decrease in temperature, decrease in vapor. Increase in temperature, increase in vapor. So the metal is the one which is going to give the latent heat of vaporization for the liquid. Okay. So that is the metal retains heat and metal gives or donates heat. So that is the reason why you must choose a metal which will hold heat and also deliver the heat to the liquid. This is another important point which you have to know. What are the effects of circuit back pressure on vaporizer output? There are two effects. One is called the pumping effect, another is called the pressurizing effect. What is pumping effect? This is a very common question, exam question, repeatedly asked. When will it happen? Is it happening during spontaneous respiration or is it happening during controlled ventilation?
During spontaneous
Spontaneous ventilation, sir. There is a retro.
Spontaneous ventilation.
pressurizing effect is during controlled ventilations.
Pumping? Spontaneous respiration, because you are all not used to leaving patients on spontaneous, isn't it? Everything nowadays you paralyze, control, so you are more tuned to control ventilation all the time. But earlier days we used to use lot of spontaneous ventilation for small short procedures. So spontaneous ventilation, there is always a patient's negative pressure which is initiating the flow of gases. Is that right or no?
Yes, sir.
Yes. Whereas in controlled ventilation, you are converting that negative pressure into positive pressure because you are always trying to squeeze the bag for inspiration and relax the bag for expiration. So when you squeeze the bag, there will not only be a pressure transmitted towards the patient, but the same pressure, can it go backward also?
Yes, sir.
Yes. So it will go and block the output end of the vaporizer. So vaporizer, remember, it is a chamber which has an inlet through which the fresh gas flow is coming. It may be part of the fresh gas flow like in variable bypass, and part will go straight through the back bar tube, and the gas which has entered the vaporizing chamber will pick up the vapor and join the bypass gas at the outlet. Okay. So if the back pressure is transmitted on to the outlet of the vaporizing chamber, what will happen? Will the gas be able to go forward or stay there for some time? See, it is a continuous flow machine. Flow meter is not stopping when you are squeezing the bag and giving a pressure, and when the pressure gets transmitted back towards the vaporizing outlet, the flow meter is still delivering the gases. It is not stopping to accommodate this back pressure, isn't it? It's a continuous flow machine when we are using our regular workstation or whatever anesthesia machine you are using. Do you understand that or not?
Yes, sir.
Yes. So it is a continuous flow. So there is a forward flow coming from the flow meter going into the vaporizing chamber or the bypass, that is also coming. And when you squeeze the bag during controlled ventilation, the back pressure is transmitted towards the outlet of the vaporizing chamber, preventing the forward flow of the gases coming from the bypass channel as well as the vaporizing channel. So what will happen to the gases? Will they be pushed back into the vaporizing chamber to some extent?
Yes, sir. There will be backflow of
back flow, back pressure. It will be pushing that into the vaporizing chamber. So will it pick up more vapor?
Yes, sir.
Yes. Why you are all hesitating so much? It will have to pick up more vapor. Okay. So the next breath, once you relax and then you allow the next breath when you squeeze, more than the fixed dial output will be going there. Okay. This is called the pumping effect. Pumping effect happens at the outlet of the vaporizer. Is it clear?
Yes, sir.
Pumping
Yes,
effect
sir.
happens because of the partially transmitted positive pressure from the reservoir bag coming backward towards the outlet, it causes an increase in the flow. I will show you a picture to make you understand that what changes happen due to pumping, what are the changes due to pumping effect. During generation of a positive pressure, the bag is squeezed. So pressure in the breathing system increases. This pressure is transmitted back both to both the bypass channel and also the vaporizing chamber outlet. The fresh gas tries to move forward and gets compressed both in the bypass channel and in the vaporizing chamber. During sudden release, this is the next step. So you are squeezing the bag. These are all the changes that are happening. When you release the bag pressure, what happens? When the positive pressure is suddenly released during expiration, the previously compressed gases suddenly expand in all directions, and some of them rapidly expanding gases enter the inlet of the vaporizer and cross over to the bypass channel, and then they also final output concentration. Normally, a vaporizer's bypass channel does not have the vapor. It should not have any vapor at all. So this vapor due to pumping effect is addition, and this bypass vapor flows across to the exit and it meets the vapor from the vaporizing chamber. So the addition of the bypass vapor to the vapor from the vaporizing chamber raises the final concentration of anesthetic delivered, and that is called the pumping effect, increases the delivered concentration. I will show you the pictures which will make you understand this concept easily. Now here you can see the bag is being squeezed. Okay, so pressure is going partly towards the patient and it is partly coming out to the common outlet from the bypass chamber as well as from the vaporizing chamber, and you can see fresh gas is constantly flowing here. So what happens is fresh gas is partial because it's a variable bypass, part of the gases are coming here. This pressure is transmitted both to the bypass channel as well as the vaporizing chamber channel. And the gases, next picture, if you see, these purple dots are the vapors that are coming there. So they are not allowed to come out through the outlet, rather they travel towards the inlet where the fresh gas flow is coming. And in the next picture, you can see these are entering here at the inlet and then joining the bypass channel also. You can see that this is the arrow mark is clearly showing how the vapor that has been formed here has been pushed back into the bypass channel, where normally it should be a pure fresh gas without any vapor. But this pumping effect causes the vapors to enter the bypass channel here and then mixes with the fresh gas flow that is coming here, and whatever has already been carried here to the outlet, that is also coming. So 1 + 1 2, you have a increasing number of molecules coming here causing the pumping effect. Okay, so ultimately what you get is a higher concentration by the pumping effect. This is a very important thing that you have to remember and very commonly asked question in the exam. So this plays a more important role in your altering the vapor output from the vaporizer. Is this clear to all of you?
Yes, sir.
Okay. Now the second effect, what are the question will be asked is, what are the methods of reducing this pumping effect so that you will get the correct delivery of the vapor instead of increase in the vapor concentration? How will you achieve the correct delivery of the set dial concentration instead of getting a higher concentration? What are all the changes that have been made in the modern machines so that you get the correct, if you say keep say 2% sevoflurane, it should all the time deliver only 2%, not 2.5 or 3% due to the pumping effect. So how is that achieved? What are all the changes that you can make to achieve that concentration?
There's a unidirectional valve in the
Fantastic. Valve at what level?
Can increase
inspiratory.
See, always remember the vaporizing chamber has got an inlet and outlet. And if you remember that, you will be able to easily understand this concept. unidirectional valve to prevent the transmission of pressure towards the vaporizing chamber, correct?
Yes, sir.
Towards the outlet of the vaporizer. Very good. That is first option. Then
increase the length
of
Vaporizer outlet.
to
outlet, not outlet.
Inlet into
You have to
vaporizing chamber.
because the
Inlet, sir.
mixing happens at the inlet level. You have to increase the length of the inlet. Very good. Okay. So see, this is the long inlet tube. Okay, if the tube is long, then there is not much of gases can. As you showed you in the earlier picture, it was able. The arrow mark was going curving up into mixing that. Whereas if you have, it will partially go into the inlet tube, but then next flow will push it back and it will have to come only out through this. So having a long inlet tube to the vaporizing chamber will prevent the mixing of the vapor with the fresh gas flow passing through the bypass channel, number one. Number two, increase the resistance by in this area. So when you outlet area, if you increase the resistance by adding a to prevent the back pressure getting transmitted to the outlet. The third option is to have a one-way valve so that whatever transmitted pressure is there, that is prevented from going on to the outlet of the vaporizing chamber, and it will all only go towards the patient. So these are the three options that you have, and so this is the position how the one-way valve can function. It will open when the gas is flowing during inspiration. It will close when the that is even during spontaneous or control, it can immediately close when the back collapses, and it will not allow any back pressure to come in. Okay, so that is how the three adaptations that you can do for reducing the pumping effect: long inlet tube, increase the resistance at the outlet tube, or have a one-way valve at the outlet tube. These are the three options that you have to mention in your answer in the exam. So what is pressurizing effect? That is the next thing. So it is also because of the same back pressure effect. Okay, and see, it actually supposed to lower the concentration instead of increasing the concentration. It is supposed to lower the concentration. So the pressurizing out, the output of some vaporizers decrease when there is a back pressure. This effect is greater with the higher flows and larger pressure fluctuation and lower vaporizer settings. These changes in vaporizer output caused by the pumping effect is usually greater in magnitude than those associated with pressurizing effect. So in the exam, simple one-way answer you can remember is pumping effect will also cause a lower concentration if there is a lower gas flow, whereas pressurizing effect with a high gas flow, it will cause a lower concentration. So this is the answer that you have to give. But in total, examiners will ask you what will happen to the vapor output. Pumping effect increases the concentration, pressurizing effect decreases the concentration. That is the answer that you have to give. Now, what this X6 we have already seen gas fluorine. What are the safety features incorporated in the modern vaporizers for pre-fill system, low filling port, and all these things already discussed. What are the hazards of vaporizers? This can be sometimes asked. Even though vaporizers are very, very essential to deliver the safe concentration to the patient for maintaining the plane of anesthesia, there are hazards also for the vaporizer. What are the hazards? Nobody wants to answer. So wrong filling, misfilling, contamination, underfilling, and also tipping, overfilling, and leaks. These are the 6 important things that you have to remember. Misfilling, and especially by the pour method, where you just remove the cap and directly pour from the bottle, there is always a chance that you can fill up with the wrong agent. That is why we have now the heat filling and quick fill, easy fill. All these things are safety measures to prevent a wrong filling. Then there may be contamination, there may be underfilling. These should decrease vapor output. So you should have that minimum level always present to have the correct output. And you should not tip the vaporizers, especially when you have a removable vaporizer with the interlock system. There's always a chance that you can tip the vaporizer and the liquid may come out. Of course, the X7 that filling is also prevented, and overfilling may result in high output. And also, when you fix it by constantly removing it and refixing it in the back bar, there can be leaks. These are all the how the interlocking system works. This is the picture to show that. And I didn't identify the method of filling. Already you can see that. These are all the methods to show how it can be done. What is the name of for the agent specific pin safety system that is used in the heat filling system? Is there a name for that key? It is called Fraser Sweatman pin safety system. What are the components of this system? The key bottle collar, adapter tube, and vaporizer filler receptacle. Okay? So these are the things, how you fix it and how you use it. This picture will tell you how it is being done. And so this is a close-up view, how you insert and then fill that thing. So these are the how step by step how you do that, how to fill that bottle. Because isoflurane is a little difficult unless you put the correct groove into the slots. You cannot fix it correctly. This is the easy fill where the bottle cap already has that specific filling method component. Dalton's law of partial pressure. This is also another thing. The partial pressure of total volume gas percent. This also is plenum. Of course, we have talked things full or pressurized. The plenum vaporizers are the modern vaporizers. Okay, copper kettle, which I was talking about it. Okay. It is also a measured flow, older version. Method of vaporization can be bubble through also, temperature compensation, no calibrated, multi-agent, put of circuit. Okay. Tech 2 and 3 vaporizer differences. Sometimes that. Tech 4 is the whole Tech 5. Sometimes you will be asked what are all the changes that have been done from one vaporizer to another. Then you have to know all these things that you can find in all. These are different models of desflurane vaporizer itself by different companies. And you can see there will be slight difference in the, here the filling system, this is different, here it is different, here it is different. So small changes are. So this is Draeger, this is Tech 6 and Penlon. What are the methods of temperature compensation? How it is done? That is also sometimes asked in the examination. Any idea?
Using
Tell
thermostat,
me the
electronically heated thermostat, then thermobuffer.
Bimetallic strip, that is the most common thing. Bimetallic strip. What happens because metal rod temperature compensating valve there. So importance of temperature is whenever the temperature is low, vapor output will decrease. Whenever the temperature increases, vapor output will increase. So to deliver a constant temperature, you may have liquid bellows, temperature compensating valves may be there, and there may be different thermal expansion metal, one which will expand at high temperature and one which will expand at low temperature. So if you have both of them fixed together, it will, depending upon the temperature, it will change position. That can cause opening or closing. This picture will tell you how they can bimetallic strip temperature compensation. The gases coming into the vaporizing chamber are blocked and the temperature is normal. The temperature comes down, the bimetallic strip bends backward and the opening becomes more, so more gases enter and the vapor output will be increased. So at whatever, if the temperature is very high, then it will close and prevent more gases coming in. And that time also it will maintain the same constant output of the vapor. These are all the easy fill things, and was Aladdin, all of you have been aware of that. So that all these things. So this is a comparative chart to show what are all the changes. This is available in the books, and just before exam you can go through to see. Because sometimes examiners may ask you what are all the improvements that have been made in the modern vaporizers, and you have to know that. And lastly, what is DIVA? Any idea? Direct injection of volatile anesthetic. And how does it work? So it is a measured flow vaporizer for all modern anesthetic, including just fluorine. It has two sections: a plug-in vaporizing module, which is specific for a particular agent, and that's the your thing. So storage liquid, there's a pump tank, there's a metering liquid, evaporation chamber, patient circuit. So it is directly injected into the circuit, and this may be the thing that may be cast in the future. So this is the vaporizer for such a thing. The hazards associated, so we have seen overfilling, leak, electronic failure, reverse flow, and what is this? Any idea?
Anaconda system.
Excellent. This is an anaconda vaporizer. Okay, this also comes under vaporizer because it uses the sevoflurane to sedate the patient in ICU who are mechanically ventilated. So you can use that one thing voice sample attached to that. So this is what is anaconda, where it is commonly used, advantages and disadvantages. It's a mixture of anesthetic vaporizer and a HME, the combination. And it is a device meant to be used mainly for sedation in intensive care and outside operating rooms. It is designed to deliver only isoflurane and sevoflurane. These are the two agents commonly used. Available presently in two different internal volumes of 150 ml to be used in patients with high and low tidal volumes. Attributions of Arthur Goodell, all these things can be asked by examiners if it is with that. So I'll just stop there, and do we have time to discuss breathing circuits? Will we do that? Shall we have it next class? Am I audible to all of you?
Yes, sir.
Yeah. What is your choice? Want to continue with breathing circuits, or shall we have it next class?
We'll continue, sir.
Continue. Okay. Right. So more enthusiasm is there. Good.